Hello, guys. So I hope that you are doing well. Well, I'm recording this video because the idea is to explain the next topic, which is sample space diagram. Okay, so a sample space diagram is basically a matrix. When we say a matrix, is that it has columns and it has rows. Okay, so and that those columns and rows are constituted or are established due to the number of possible outcomes each of the events have. So the idea is the following. The idea is like normally we are, or in this case, what we're doing is we're combining two events, okay, that they have different or the same sample spaces, and when we combine, we are creating the new sample space. Okay, that is basically the idea. For example, here we have a small example. The context of this is the game of rock, paper, and scissors, and here we have the outcomes or the sample space of player one, and here we have the sample space of player two. Okay, so if you notice here, we are generating each of the new outcomes when we combine the possible outcomes the players choose to play. Okay, so more or less that is the idea. So let's use an example to explain it better. So here it is. First example, it says, suppose that we have two fair dice which are labeled from 1 to 6. Okay, construct a sample space diagram. Okay, so that is what I'm going to do first. So when I construct a sample space diagram, notice that the context of this is two dice. Okay, here I have my two. Oh, sorry, I need to charge or to plug my charger. Okay, so what I was saying is this. So now what I'm gonna do is I'm gonna write in columns the different outcomes dice number one has. Okay, so in dice number one we can get 1. Okay, notice that I'm writing it as columns. Or 2, we can get 3, we can get 4, 5, or finally 6. Okay, now in the other dice, the same thing. Okay, in this case, they have the same possible outcomes. The sample spaces are the same. Okay, so notice that I already created my matrix, but now I need to figure out how we're gonna link these numbers or these outcomes. Okay, if you notice, it says that when we add the results. Okay, so that means that the operation that is going to be here is going to be an addition. Okay, not always is addition. Okay, so in this case, now knowing that that is the operation, what I'm going to do is I'm going to add. Okay, so 1 and 1, 2, 1 and 2, 3, 1 and 3, 4, 1 and 4, 5, 6, 7. Okay, next one, 2 and 1, 3, 2 and 2, 4, 2 and 3, 5, 6, 7, 8. Okay, and I'm going to complete it now. I think that you already got the logic. Okay. Okay. And here I have all this that I mark in purple. All of them are the possible outcomes, that each of the possible outcomes when we combine them. Now we are ready to answer the questions that are given there. Okay, so the first question says, what is the probability of getting an 8? Okay, so In this case, normally in probability, we call x to the result. Okay? The result is going to be x. So probability that the result equals 8 is going to be, and now we need to see the sample space diagram. Okay? Remember that in probability, the numerator of the probability is in how many ways that event of getting as a result A could happen. Okay, so if you notice, that is labeled clearly. It is clearly here. 1, 2, 3, 4, 5. So we can get an 8 in 5 different forms. So it's 5 out of the total. Okay, maybe you don't want to count the cells, but if we multiply 1, 2, 3, the 6 columns by the other 6 rows, we know that in total we have 6 times 6, 36 options. Okay, so the probability of getting an 8 is 5/36. Okay, now let's go to the second question. What is the probability of the result to be greater than 8? Okay, so what is the probability of the result being greater than 8? Let's see that. Okay, so greater than 8. I'm going to erase it here so we don't get confused. Okay, greater than 8. Let me change the color as well. Here. Okay, greater than 8, 9, 10, 11, and 12. So let's see in how many ways we can get a number greater than 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In 10 different ways. 10 different ways out of 36. So if we divide by 2, it's going to be 5/18. And that is how we use the sample space diagram to answer a question that with the sample space diagram is really easy. But when we see that without it, it's kind of complicated to see all the possible options. So as you can see, the purpose of sample space diagram is to visualize better the whole sample space. Okay, that is why it's named. Let's see the next one. Okay, another example, and then you go to the practice. Okay, so now we have another dice which is called Zickerman dice. Okay, and there's something that says here. It says it is claimed that when this pair of Zickerman dice is thrown and the two numbers obtained added together, the probability of each total is just the same and as if the two dice were numbered with 1 through 6. Okay, verify this claim. So let's see if that is true. Okay, so now I'm going to keep this here because I need to write the numbers. So the outcomes for the first dice: 1, 2, 3, 3, and 4. Okay, so I'm writing the columns. Okay, here it is. So for the first dice, these are the possible outcomes: 1, 2, 3, 3, 4. Okay, notice that I repeated the 3, no matter that it was said once. Okay, let's go to the other dice. So to the other dice, the options are 1, 1, 3, 4, 1, 3, 4, 5, 6, 8, 5, 6, 8. Let me see. 1, 3, 4, 5. 1, 3, 4, 5, 6, 8. Very good. Okay. And again, we are adding in this case. Not always is adding, guys. Sometimes it's going to be, the operation is going to be changed. So let's combine them. Okay. So I'm going to generate the outcome. So 2, 3, 4, 4, 5. Here is 4, 5, 6, 6, 7. Here is 5, 6, 7, 7, 8. Here is 6, 7, 8, 8, 9. Here we have 7, 8, 9, 9, 10. Finally, 9, 10, 11, 11, 12. Okay, so let's see if they claim that the probability of each of the results is the same no matter in one or the other. Notice that they look very similar. Okay, so let's try it. Okay, so it says, let's start with, for example, 2. Okay, the probability that the result is 2. Okay, in how many ways? 1 out of 36. Okay, because this is also a matrix, 1 out of 36. If you notice here, 1 out of 36. Okay, let's see. Probability that the result is 4. Let's see with 4. Okay, 4, 1, 2, 3. 3 in total. And here 4, 1, 2, 3. Okay, so notice that it is the same. Okay, 3 out of 36. Okay, I think that there is one that is not the same. Sorry, it's because I made a mistake here. Here's 1 and 2, 3, and here's 1 and 2, 3. No, yes, it is correct. It is correct. So look at this. For 3 is not the same. In 3, we have 2. Here in the normal dice, 2 out of 36. And in the Zickerman dice, notice that we have 1 and 1 here. Okay, so we have 1, 3 here, but there's no other 3. 1 out of 36. So no, it's not the same. It's not the same. I'm trying to check if maybe I added something wrong, but it's not the same. 1, 2, 3, 3, 4. Let's see the outcomes just to see if I made a mistake. 1, 2, 1, 2. Oh, sorry. There's a mistake. There's a mistake. 1, 2, 3, 4, 5. Yes, there's a mistake. Notice that I just wrote 1, 2. Okay, and there are 2 number 2s. So let me fix it. It's just this column. Here we have it. Okay, so now I think that now is gonna work. 3, 3, 3, 4, I'm sorry, 5, 5, 6, 6, 7, 7, 8, 8, 10, 10. Okay, now I think that is right. Let's see. Let's compare again. So now, options to get a 3, 2 out of 36. Here, 2 out of 36. Let's think. 6. Let's see, 6. According to the Zickerman dice, to get 6, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 out of 36. Here, 1, 2, 3, 4, 5 out of 36. Probability of getting a 9, or yeah, 9. 1, 2, 3. Notice 1, 2, 3. Here, 1, 2, 3, 4. 4. There's one missing. You see, 1, 2, 3. I think that there's one that is missing. 4 and 5. 4 and 4. It seems that the 9 is the one. Ah, no, here it is. Here it is. Not this. 1, 2, 3, 4. So yes, it seems that both the Zickerman dice and the normal dice, they have the same probability of getting each outcome, okay? If you find one that is not the same, please let me know, okay? But based on what I can see here is the same, okay? So guys, as you can see, basically the idea was to exercise how to apply the sample space diagram, okay? Now, based on this is incorrect, okay? But based on this, you should go to a practice. Now, if you go to the Google Classroom, let me show you. Here, when you go to the Google Classroom, this is your Google Classroom, and go to classwork, okay? Here, you're gonna find something that says probability sample space, okay? I'm gonna do it again. And here you have 5 different problems, okay? And the answers are just below, okay? So do them and check your answers with the answers that I gave you, okay? So if you have any question, please just let me know, okay? See you guys. It was a pleasure to teach you. Bye.